Bill, a person with technological know-how, has been intriguing us with state-of-the-art discoveries and the mysteries of vintage technology for many years. Bill Nye has taken our hobby to the last frontier, exploring its enigmas as he introduces us to the vast expanse of space that surrounds us and stretches infinitely above. Now, Bill breaks his silence on the most recent photographs from the James Webb Telescope, offering us a glimpse into the universe as it existed more than 13 billion years ago, fundamentally changing our understanding of the cosmos and our perspective on life itself. This telescope is making groundbreaking discoveries about planets, distant galaxies, and much more. It represents a modern scientific leap forward and serves as a worthy successor to the Hubble Space Telescope. But what makes the JWST photos so unique that they challenge our expectations and theories, and what does Bill have to say about them? The development of this telescope was the result of years of work by scientists and engineers, and it was launched on Christmas Day, 2021. The telescope's deployment proceeded smoothly over the following months, and by the end of June 2022, scientists began discovering thousands of new galaxies, older and farther away than previously known. Some of these galaxies may have formed 150 million years earlier than Hubble's oldest discovery. Additionally, the telescope can capture enough light from celestial objects such as exoplanets and stars to reveal their composition and trajectories through space. Dylan explains that these findings are already beginning to reveal, in incredible detail, the atmospheric composition of planets light years away, allowing scientists to assess their potential to support life as we know it. One of the most recognizable images from the Hubble Space Telescope has long been the Pillars of Creation in the Eagle Nebula. While Hubble primarily detects visible light, it could not capture the process of star formation within these structures. However, the James Webb Telescope's infrared imaging has now revealed clusters of protostars appearing as tiny red dots against the background of the pillars. These forming stars, several times larger than our solar system, are still in the process of gathering mass. Dylan explains that at this stage, they are not yet burning hydrogen, but as more material is drawn into their cores, they become denser until nuclear fusion ignites, causing a dramatic rise in temperature to around 2 million degrees. The different colors in the image represent infrared wavelengths, which are mostly invisible to the human eye. The blue portions of the image correspond to visible light, while red highlights infrared radiation. As protostars emit radiation at wavelengths 6 times longer than what the human eye can perceive. According to Bill, this image not only showcases the Webb telescope's infrared capabilities, but also provides an unprecedented view of star formation, offering insights into how stars like our Sun are born. The first exoplanets were discovered in the 1990s, and today, more than 5,000 confirmed planets orbit distant stars. However, only a fraction of them have been directly imaged. Most exoplanets are so distant that they can only be detected when they pass in front of their host stars, dimming the starlight slightly. The first direct image of an exoplanet was captured in September of last year. This planet, identified in 2017 and named HIP 65426b, was observed using the Webb telescope's coronagraphs, which block out the overwhelming light from the host star. The planet is a massive gas giant, nearly 12 times the size of Jupiter, orbiting its star at a distance 100 times greater than that between Earth and the Sun. In addition to its remarkable infrared sensitivity, the Webb telescope's ability to capture faint light has allowed astronomers to study distant galaxies in unprecedented detail. The Ghost Galaxy, officially known as M74, is challenging to see in the night sky. However, infrared imaging has revealed intricate structures within the galaxy, including strands of warm dust and gas emanating from a bright central region that appears in electric blue. These new images illuminate star-forming regions scattered along the galaxy's spiral arms. By combining images from the Hubble and Webb telescopes, scientists have created a stunning composite image that highlights both optical and infrared views of the galaxy. This composite image produced by researchers at the European Space Agency (ESA) as part of the FANGS project, utilizes data from Hubble, Webb, and ground-based telescopes to study 19 nearby galaxies in infrared wavelengths. Webb's sharper observations at longer wavelengths enable astronomers to identify star-forming regions within galaxies, pushing the boundaries of what we know about cosmic evolution. The Webb telescope can accurately measure the masses and ages of star clusters and analyze the properties of tiny dust particles drifting through interstellar space. In an image of the distant star WR140 taken in July last year, astronomers observed a distinctive diffraction pattern, a common artifact in telescope images. However, surrounding this bright star was an unusual series of concentric rippling rings. These rings, in contrast to the diffraction pattern, are a characteristic feature of massive Wolf-Rayet stars, which are in the late stages of their lives and have already expelled significant amounts of hydrogen. The interaction between WR140 and a smaller companion star is responsible for the unique shapes of these rings. The Webb telescope's primary mission is to observe the most distant galaxies in the universe, and in mid-December last year, researchers announced the discovery of 4 of the oldest known galaxies ever seen by Webb. These galaxies date back 13.4 billion years to when the universe was only 350 million years old, just 2% of its current age. These 4 ancient galaxies were initially believed to be among the oldest structures in the universe. Much like the hundreds of other galaxies identified by Webb, researchers determined their ages as part of the James Webb Advanced Deep Extragalactic Survey project using Webb's near-infrared spectrograph to precisely measure their distances. The universe's expansion stretches light waves, a phenomenon measured by redshift, with the highest redshift recorded so far being 13.2. These galaxies are older than astronomers expected to find, but for the first time, Webb allows us to discover and confirm the existence of protogalaxies at such great distances. Meanwhile, Webb has also conducted an in-depth study of an exoplanet orbiting a star in the constellation Virgo. This planet, known as WASP-39b, is located 700 light-years from Earth and orbits its host star 8 times closer than Mercury orbits the Sun. A Saturn-sized gas giant, WASP-39b experiences extreme temperatures as it orbits its star. Its thick atmosphere contains sulfur and silicate clouds, including detectable amounts of sulfur dioxide. Using 2 of Webb's spectrographs, scientists were also able to identify carbon dioxide in the planet's atmosphere, marking a significant step in the study of exoplanetary atmospheres. Let me know what you think in the comments. If you enjoyed this, don't forget to like and subscribe. See you in the next video.